problem number 3, we need our calculations and our conclusion. So what I've done is I've kind of kept my data here for the calculations. So this is from 1. Since we have Sx, that's going to be a t distribution. So we're going to go x bar minus mu, or mu sub naught, that's the null hypothesis value. This is number 3a, by the way. Divide by Sx, I don't know what's going on with my throat, square root of n. This is going to give me the t value. Or you can do all that, and all the information's there, you can plug it in. You can do the t-test in the calculator. Now, I've got a lot of this stuff written down from the previous problem, so I'm not going to rewrite a lot of what I put in, but I am going to go through the t-test. So that means I'm going to go to stat, tests, and the second one down is the t-test. That's going to do this standardizing for me. And it's going to give me a p-value. It doesn't call it p-value, it just calls it p. So in this problem, I don't have data in a list, so I'm going to go to stats. And the mu sub naught, that's the null hypothesis. That's going to be the 64.2. Uh-oh, what did I do? .2. The x bar, that's the 63.5. The Sx in this problem is 3.7. N is 48. Excuse me. And differs. So that does not equal. So I'm going to calculate that guy. And so the t-test gives me mu does not equal 64.2. T equals negative 1.31. You can round a little bit, maybe we go 1.311. P, this is the p-value. 0.1, boy, that rounds, I'm going to say that's 0.2. If you're writing that for the AP, I think you can round it like that, but maybe you'd run it out 3-4 decimals just so that they know. Make sure you're rounding it correctly. The x bar, the Sx, and the n I've already got written down up here, so I'm not going to repeat those. This is the thing that I really care about. Now the p-value is 20%. That's larger than any reasonable alpha. So in this case, we're going to be in the body of this does not equal. And we don't need to double this because we did it on the calculator. If we did it here and read off the t distribution, we'd have to double that p-value. But here the calculator does it for us, so we're good. So I'm going to say we fail to reject the null. And conclude. I'm going to phrase this a little bit differently just for the fun of it. The evidence is not strong enough to show that the girls' height is significantly different. Maybe I'd even add at this high school. Then the null Something like that would work great. That could maybe be shortened up a little bit too, but that gets the idea across for sure. Fail to reject. We do not have strong enough evidence. We lack significant evidence. Something along those lines. Okay. Now B, I'm going to flip this around here and get my data for B. And I'm going to slide this down. So this is the data that I have. It's a proportion. So the calculation that I would use is going to be p hat minus p, or p sub naught, which is just the null hypothesis. It's the p here, over the square root of p sub naught times 1 minus p sub naught all over n. And that's going to give us a z, so we would take that to table A. Remember, the z is not the probability. You got to go to table A on that. But we have a 1 prop z test, and that is the short. So again, I'm going to go to stat, and what it's going to do is it's going to do all this for me. Tests. Oops, wrong one. It's down at 5. 1 prop z test. Now, the null hypothesis here, that's the p sub naught, is 0.25. Our x was how many successes did we have in our sample. And in this case, we had 28 people that said that they danced in the rain out of 80 people that were surveyed. And this is a greater than. So we're saying that our proportion is greater than the null hypothesis. That's what this is saying. So I'm going to choose that and go down here to calculate. So maybe I write this down. P sub naught, 0.25, x, 28, n, 80, prop greater than p sub naught, and I get a z-score of 2.07 about. The p, this is the one I care about, 0.0194, I'm just going to go 0.02. And the p hat, it calculates it for us, although I think I've got it up there already. And n is 80, I've already got that guy, so that's already written in. Now, in this case, we don't have an alpha, so we have to pick an alpha. And I think a reasonable one here is to pick 10%, because whether you dance in the rain or not is probably not something you're going to sue me over or go after somebody if they get the wrong answer. So it's a Skittles problem, okay? So I'm going to compare the p-value to alpha. 0.02 is definitely less than or equal to alpha. So that's going to be reject the null. So we reject the null. And conclude there is significant evidence I kind of got that out of order. I should have said there is significant evidence to reject the null, but I'm going to deal with what I've got here. Let's see, what's the yeah, I've kind of goofed this one up. Sorry about that. How can I fix this? There is significant evidence to, how about I get rid of this conclude? Just make that a sentence. To conclude that more than 25% dance in the rain. All right. So we want to try to make that as smooth as possible. We're definitely rejecting and concluding that the proportion is higher. So I hope that helps, and maybe I'll see you for 4, maybe I won't.